Hey everyone, welcome to Office Hours.
Morning.
Morning or afternoon. Thanks everyone for joining us today. Hope everyone had a good weekend. So today we are live streaming to YouTube. And I'm getting audio from the feed. Hold on one second. I've got to mute. Okay, there we go. Yeah, so today we're live streaming to YouTube as an experiment. So welcome anyone that happens to be watching us there on YouTube. This is something we might be doing once a month just to give folks a preview of what Office Hours is, what it's all about, what we're doing. Last week we tried Facebook, so we're trying out different things to see how it all works and everything. But so this week we're on YouTube, and we'll see how it goes. For folks that are on YouTube watching us, we will not be interacting with anyone there on YouTube Live. This is a members only event, and so I'll just be focusing on the people that are joining us through the Zoom call today. But let's get started. I want to do a quick recap of what's been going on in the world of Python the past week, and there is actually quite a bit to talk about this week. There's a lot of news, so let me jump into. Might be. Sorry, give me 1 second here. Not sure I've got the right. Okay, can everyone see PyCoders Weekly on the screen? Okay, good. So we're on issue number 462, and there was some big news in the world of Python over the past week or so. One of the coolest ones that I want to lead off with is now, I guess a little over a week ago now, the Mars Perseverance rover landed on Mars successfully, and with it was carrying a helicopter that they're using to test flight on Mars. It's an experiment just to see if flight is feasible, and they can get that working. And Python is running on that Mars helicopter, which is pretty cool. And NASA open sourced a framework for flight that really the framework is written in C++, but it does have some Python bindings for some parts of it. And there's a GitHub repository with all of the code. And so you can see, the main language is C++, but about 16% of it is Python. And that's pretty neat. So Python is officially on another planet, which is pretty cool. Also, Python version 3.10 alpha release 6 is out, and this includes the structural pattern matching, which we talked about over the past couple of weeks. We've mentioned that, and this is the new match case statement that was approved by the steering council. Forget the exact date that they approved that, but relatively recently. And if you'd like to see how that works and play around with it, you can download this alpha release. Now, it is an alpha release, so this is not meant for running any code in production or anything like that. It's not guaranteed to be stable, but you could download it and play with it a little bit and see how that works and everything. Ava, you have a question?
No, not a question. On the NASA helicopter.
Yeah.
NASA uses Python kind of across the board in many projects.
Yeah, they do. Yeah. They do. Yeah, that's I know that they use it for a lot of different things. And I know even in the world of astronomy, beyond NASA, but just astronomers in general use Python quite a bit for analyzing data from telescopes and things like that. But I think this is the first case of Python actually being on a different celestial body. So that's pretty cool news there. Some other big news, the Python Developer Survey 2020 results have been released. So this is a survey conducted by the Python Software Foundation and JetBrains, the makers of the PyCharm IDE. They team up to do this survey every year, and those results are out. I've not had a chance to actually go through the results, so I can't really comment too much on them yet. But it's always fun to see how that plays out, what things are changing each year, and just kind of how Python is developing from year to year. We also had the 20th anniversary of the Python Software Foundation. Last week, we mentioned that Python itself was celebrating its 30th anniversary. This week, in fact, I think it was March 1st, was the 20th anniversary of the Python Software Foundation. Something else I wanted to discuss was a new feature that may or may not be coming up in a future Python release. I'm not sure if it would be eventually included in Python 3.10, but it might be a later release. But this was a Twitter thread from Raymond Hedinger about something called keyword arguments in indexing. So if you've seen keyword arguments in functions, you can pass an argument to a function as a keyword argument. So maybe it has an argument called name or something. You say, like a greet function, right? That you pass a string to it and it says hello, whatever the string you pass to it. Well, if that argument is called name, you could say greet parentheses name equals and then the string. That's a keyword argument. Now it looks like there's a chance, and a pretty good chance, that indexing will also support these like keyword style arguments. So Raymond posted this, and the original tweet at the top of the thread has some examples that are a little difficult to understand or parse at first sight. So you see things like you have a value, something's being assigned to this value. You have some object here called X, and you've got this index using the square brackets where we've got, okay, 1, 2, and then A equals 3, B equals 4. I mean, this looks really kind of weird. Like what in the world is going on here? And he's showing off some different features. These are not the greatest examples. He does in the next tweet say, here's some other examples from the enhancement proposal. Say you have some object called grid position. So this would be something that stores like a position on a grid, like maybe a 3-dimensional axis or something like that. And here you've got like the X position, the Y position, and the Z position. This one is pretty easy to understand here too. Matrix. So if you have a 2-dimensional array representing a matrix, you could effectively call the first index the row and the second index the column. Now, I discussed this a little bit internally with some authors at Real Python, and they were kind of confused about like what's going on here. Like, what is grid position? Is it a list? Is it like what is this thing? Now, the built-in data types and data structures are not going to change. So if you have a list, you will not be able to use the keyword indexing on a list itself. What is happening here is they're updating the signature and re-implementing the get item and set item dunder methods. Now, this is a little bit more advanced discussion here, but this is part of Python's data model. So if you're building a custom data structure that supports indexing, so you have something that's sort of like mimicking, like or not mimicking an iterable, is an iterable, and want to support the sequence protocol, which has indexing on it, or maybe something like a mapping, like a dictionary, so some sort of custom dictionary structure that supports these keyed subscripts. You'd be able to support these keyword arguments in your indexing. And the reception was very mixed. I think a lot of people saw this original tweet, and we're just very confused about these examples and like what is going on here. This looks horrible. I don't get it. Why would you want to add this? When I saw these examples, I started thinking that's actually interesting. Like I like naming things. I think it's helpful to give things names, and I like keyword arguments. I use them pretty much whenever I can. And I read through the PEP and tried to understand the motivation and everything for this. And there's lots of different, I guess, motivation for this. It comes from many different areas. One of the big ones that people are excited about is for pandas. If you want to filter a pandas series or a pandas data frame, then you have to say you have a data frame called DF, and you want to look at all elements in the, or all rows in the data frame where a certain column is greater than like 10. It's a numerical column. You say, okay, greater than 10. You have to do DF and then your square brackets, and then DF square brackets, and then the column name inside of those greater than 10. So you end up with kind of a weird notation there, and I'm going to show you what I mean just quickly in a terminal. If I can get it to switch, there we go. So you would have something like DF and then DF, let's say age. Maybe it's got ages of people greater than 10. So you would have to do something like this. This would be the notation you would use to filter all rows in the data frame where the age column has a value greater than 10. With the new keyword indexing, you'd be able to do this. Something like this, or age equals 10 if you wanted to have it be equal to. So that's a little bit easier to look at, a little bit easier to parse, and a little bit friendlier on the eyes than having all these square brackets everywhere. So that would be one use case. There are some use cases in typing when it comes to type annotations and custom types and things like that. So there's a lot of motivation for it. And the core developers were they seemed pretty, like everyone was pretty much on board with this PEP and going ahead and including it in. So it does look like there's a really good shot that this will be accepted by the steering council and will find its way into the language. So that's pretty big news as well. And as far as new things going on in the world of real Python, we have a new article on Python and MongoDB connecting to NoSQL databases. Actually, this might be a course. Oh, no, it isn't. It's an article. So new article on that. So if you work with NoSQL databases like MongoDB, that would be a good one to check out. We also have a new course on navigating namespaces and scope in Python. Now, this I'm excited to see come out because this is a topic that a lot of beginners don't get a lot of experience with and can be the source of a lot of confusion and bugs in Python programs, especially because scope, if you're coming from a different programming language, if you're an experienced programmer and just starting with Python, scope works maybe a little unexpectedly sometimes in Python. So this would be a great course for both beginners, like advanced beginners, and even more advanced programmers that are new to Python to check that out to understand how scoping and namespaces work in Python. There is also a new article on Brython, which I believe Brython is sort of this mashup of browser Python. So this is a way to execute Python in your browser, and it's kind of a neat deal. In fact, if you've taken any quizzes on real Python, we use Brython to make those quizzes work. So you can type in what I mean by that is we have some questions on our quizzes that allow you to type in some code, and then it will tell you whether or not the code you entered was correct. And what we're doing is executing that Python code using Python in the browser. That way it's being executed on your machine, and running basically some tests or a few assert statements to see if the code works and sort of passes a contract that we've set up that we determine is the correct a correct solution to that problem. So Python is a pretty neat deal. It's not the only way to run Python in the browser, but it is something that I think it's one of the older ways, a little bit more established, and so it basically the Python gets compiled to JavaScript, is how this basically works in the back end. So it's taking that Python, compiling it to JavaScript, executing it, and then returning the answer. And it does not support 100% of the Python standard library, but a good portion of it. So it's definitely a neat technology. This is a very thorough article. Talks about installing Python, understanding how it works, how to use it in your browser, how you can interact with JavaScript through Python. So you could create an entire sort of front end script using this and not have to use any JavaScript at all for your website if you wanted to do something like that. So it's an interesting project, and there's a lot there to take a look at. We also had a new podcast episode come out, and we interviewed. I say we. I wasn't involved in this podcast episode. It was just Chris. It's called "The Challenges of Developing into a Python Professional." We had Real Python author Dane Hillard on to talk about his book "Practices of the Python Pro." So that's a good discussion, and also an excellent book to read. That's published by Manning, and I've read it. I've got a copy, and it's a really good book if you're curious about, I guess, what like professional Python development looks like, and sort of best practices and things like that. It's definitely a good read. Mainly focusing on web applications and application design and things like that. The final thing I wanted to talk about, I think, let me make sure I'm not missing anything I wanted to mention. Yeah, there's lots of good stuff in here, but the big thing I wanted to mention here is this article, "Semantic Versioning Will Not Save You." This was written by I'm gonna botch his name, but Heineck Schalwak, and Heineck is he's pretty active on Twitter. If you're on Twitter, you follow him. He posts a lot of good stuff. His blog has a lot of good stuff on it when he makes posts. And this was a really, I thought, a well-written response to a recent sort of quote-unquote controversy that came up involving Python, specifically the cryptography package, which is depended on by a lot of other libraries. So it's not something you probably use yourself very often, but it's something that a lot of libraries use that you've probably used before, like things like Flask and things like that. So there was an issue where they changed their build system to use Rust for a certain low-level code. And Heineck says this caused an emotional GitHub thread, and it is a pretty emotional GitHub thread. I went through the majority of it, and it's pretty wild. The emotions were definitely in plain view there. And in short, enthusiasts of 32-bit hardware from the 90s aside, there was a vocal faction that stipulated adherence to semantic versioning from maintainers, claiming it would have prevented all the grief. So they made this change to using Rust for certain low-level code, which meant that in order to compile cryptography, you needed to have Rust installed on your system. Now, there were some users of cryptography that were focused on architectures that did not support the latest version of Rust or a version of Rust that was compatible with this. So they were not able to compile cryptography. Now, this doesn't affect the vast majority of users because you're not compiling cryptography from scratch. You're downloading a wheel, which is already compiled from the Python package index. So it's a very small set of users that were affected by this. And they were saying that semantic versioning was being broken here. So semantic versioning is a way to version a really anything. You could use it for, doesn't have to just be software, but that's, the context we're in. And it's what Python uses. So you have like a major version, like 1, a minor version like 10. So with Python, we're the latest version of Python that's available, that's not in alpha, is 3.9.2, I believe now. And the 3 is the major version, the 9 is the minor version, and then the 2 at the end is what they call the patch version or the micro version. So that's what the semantic versioning is. You have a major, and then a dot, and then a minor, and then a dot, and then a patch version. And it's not just the version number. There's also this promise that comes with semantic versioning that as long as the major version doesn't change, nothing will break. And you can update, here Heineck says, you can update your dependencies without prejudice. So if the major version hasn't changed, in theory, according to the sort of ideas of semantic versioning, you should be able to upgrade that without any problem. Now, what Heineck, what his point in this article is, and it's a very good point and very, it's something to keep in mind when you're working with software, is that semantic versioning is it's just an idea. It's just a framework for versioning. There's nothing about semantic versioning that makes any actual guarantee. So when you're updating dependencies that are using semantic versioning, while they're supposed to have this promise that things will not change, that is not necessarily always going to be true. And the point, I think, of the point of the article is that there's a couple of things. He does argue sort of in a footnote that semantic versioning was not actually broken by the cryptography package. Now, I won't get into that debate, so people can have their own opinions there as far as I'm concerned. But the point of the article really is that semantic versioning is great. And if you want to use it, that's fine. But as consumers of packages and people that have to maintain an application that is depending on packages, we should not blindly assume that that package developers are not going to break this promise from semantic versioning. And I think that's just a good thing to have in mind. It's really, you want to protect yourself and protect users of your application. And the best way to do that is to have lots of tests written for your application so that when you make these changes, when you update a package in your dependency tree, you can test that things are still working the way that they're supposed to, and not rely on some promise from this framework of semantic versioning. So I thought that was, it's a really interesting article. He talks about a lot of things in it, a lot of reasons why semantic versioning may break down, or why it's something you may want to maybe not consider if you're maintaining a package. Maybe you want to consider a different type of versioning. There's other kinds of versioning out there that you can use. It doesn't have to be semantic versioning. But I thought it was a really interesting discussion, and wanted to bring that to your attention. So these are things, real world things that people have to deal with when they're maintaining software. And of course, it's not specific to Python. This is just anytime you are maintaining software that lots of people use. So that wraps up the overview of everything that's been going on. It was a pretty busy week, lots of news and lots of things going on, but hopefully that gives you an idea of what's been going on in the world of Python. So at this point, I want to open it up to some Q&A and see what you guys have been working on, and if you have any questions for us that maybe we'd be able to help you out with. Anyone do anything, like build anything fun this weekend? Have any projects they were working on or anything like that? Okay, just a couple things in the chat. Jinyu says you sent me an email before class. I apologize that I missed that. Let me get my email open. Oh, I see it. Yeah, it came in. Okay, yeah, just a little bit before class here. About Python classes. And Ankit says, my question is, what are these properties in Python? I know about attributes and methods, but what is this?
So I sent a picture, David.
Yes.
I sent a picture that has a class definition. So in the definition, if you open that like a picture, it shows you what's the detail. It passed the object to the class. I'm not sure how to understand that part.
I see. So the reason I was reading Ankit's question is I think they might actually be a little bit related in a sense, or we could kind of segue from one into the other. I am going to share this picture so that everyone can see it.
Yeah.
And we can discuss it. So this is the picture you sent, and you've got a question mark. So they're defining a class called linear regression GD, and they're passing to, or not passing to this class, but they're inheriting from something called object. That's the question you have, like, what is this object thing? Yeah. So this, so object is the base class that all Python objects inherit from. Now, this is kind of an older notation. So when you, in Python 2 and in early on in Python 3, when you created a user-defined class, you had to inherit from this object class. Now, that is no longer the case. It's basically done implicitly for you. So nowadays, in the latest versions of Python 3, when you declare a class, you can just put the colon right after the class name. You don't have to put like this parentheses object, but that's what this means. It's saying that this is a class called linear regression GD, and it inherits, excuse me, from the object class. That's what that means. Now you can still do this. I apologize. I'm just getting a note that says my internet connection is unstable. So hopefully you guys can still see and hear me.
Yeah, we can hear you.
Okay, fantastic. So it's inheriting from this object class, and that's all classes in, or all objects in Python, whether it's a custom class or a built-in object, do inherit from object. But you no longer have to include that. It's optional. You could do it. In fact, you could write it this way, and everything should still work the same, but it is not necessary.
Okay, so if it's not inheriting from a particular self-defined class, I don't need this object.
You do not need it. Exactly. Okay. Now, if you are doing like a hierarchy, like you've got some other class you've defined and you want to inherit from that, then you do have to include that in parentheses. But if it's just like a base class, it's not inheriting from anything else, then you don't have to include that. Now, one thing to keep in mind, though, is there might be some very subtle differences. I don't know when this book was written and what Python version that it was using, but you'd probably want to try it like with and without the object and see if it works fine without it. There might be some very specific cases where not inheriting from object might actually cause an issue. Just to throw that out there. But in general, in the latest versions of Python, if you're using, I'm not sure the specific version was. I want to say like 3.3. It goes back that you didn't have to use it. It might even been earlier than that. But definitely if you're 3.6 or above, you don't need to include object when you're creating your own classes.
Yeah, I see. How about the other one, the self W underscore and cost underscore? How do I interpret those two things? The second question.
Is the question you have specifically about the underscore?
Yeah.
Or just you're wondering like what this underscore is there for?
Yeah.
Yeah. So this is a common way for Python programmers to indicate that this is like a quote unquote private attribute that's meant to only be used by the class itself, and it's not something that would be used by something else somewhere somewhere else in the program. So the class, when you're constructing a class, it has what's called an API, right? An application program interface. And the API is like how you work with the class, like what external objects in your application, when they consume the class, when they make calls to it, like what are they expected to be able to use? There's a fit method that they would call. There's a net input method that they might call. There's a predict method that they might use. There's a dot. I'm assuming that's eta, not ETA, like estimated time of arrival, but eta, like the Greek letter. There's like this eta and n underscore iter. Those are all attributes and methods that something outside of the class, like if you're outside of the class in your program, you would be expected to be able to use those. However, this self.w underscore and self.cost underscore, those are things that are just being used internally by the class itself to keep track of certain things. So maybe W is like a weight is kind of maybe what it looks like, and cost is something to do with like a cost function or something like that. Those are being used inside of the fit method in order to calculate certain things, but it's not something that you would use outside of the class. Like you wouldn't be expected to in somewhere else in your program access that W underscore and cost underscore attribute. Does that make sense?
Yeah. So if I create object of this class, linear regression GD, can I use the W underscore and cost underscore?
You could. I mean, they will be there once you've called the fit method. So if you create an instance of linear regression GD here, initially it won't have those defined because the init method or the dunder init method is not defining those. Once you call the fit method, those will exist. Those attributes will exist on the class. And then you could call those if you want, or access those if you wanted to. But the underscore is basically saying that it's really meant to be kind of private and internal to the class itself, and not something you would use on an instance.
Oh, okay.
Yeah. Have you studied object-oriented programming from like another language before, or is Python the first time you've seen this?
I didn't have formal training in CS. I'm just learning
Okay.
Python by reading a book and also learning the videos in the Python.
Yeah. So in many other object-oriented programming languages, there's an idea of public and private attributes and public and private methods. And a private attribute is something you can define on the class itself, and it actually will not let you use that attribute outside of the class. You'll get some kind of an error or something like that if you try to access it. That doesn't exist in Python. Everything is technically public. That's not 100% true. There is a sort of private thing they have that it's a little way more advanced, and we won't talk about that. But you can basically think of everything in a Python class as being public, and could be accessed from something outside of the class. The underscore is there as like the programmer puts that in to just say, even though you can access this, you probably shouldn't. It's really just meant to be used internally by the class itself and not externally. Now, Gregor in the chat just said, isn't the underscore usually used as a prefix? And that is true. Most times I see the underscore being used as a prefix instead of a postfix on the attribute, but I have seen it both ways, like this book is doing. But hopefully, Jinyu, does that answer your question about these? Do you have another question or?
Other questions would be like, if I finish reading your book on class, what are the other resources I should go to have a more in-depth understanding about classes? Like, this is a little difficult.
You referring to the Python Basics book? Is that what you're reading? Yeah. So to get like a more in-depth understanding of classes and the data model, the absolute best resource that I know of is Fluent Python by Luciano Ramalho. Let me get a link to that.
I see.
And I believe, I don't know if it's available yet. I'm going to throw the link in there. Yeah, Suhail mentioned the Python Tricks book from Dan Bader. That one is definitely a good next step after reading Python Basics. However, it doesn't have as in-depth of a discussion of the data model and object-oriented programming like Fluent Python does. So in particular, if I mean, really, I would recommend you read both of those, Python Tricks and Fluent Python. But to really, for me personally, when I read Fluent Python, that's when everything about object-oriented programming in Python just clicked, and it was like, whoa, okay, I really understand what's going on here. It's really well written, and it's a pretty famous book in Python as well. There is a second edition, and I think I linked to the first edition. I don't know if the second edition is actually ready or available yet. But even the first edition, I mean, is really fantastic. So
yeah, okay, cool.
And Suhail, you also mentioned that the single underscore, like the single trailing underscore, a lot of times is used by convention to avoid naming conflicts with Python keywords, and that's also true. So, for example, let me stop sharing the picture, but yeah, if you want to name something like input, right? So if you want to name a variable input because you're getting input from a user or something like that, well, there's a built-in function called input. And so if you name a variable input, you're doing what's called shadowing the built-in function. And now if you try to use the input function somewhere, once you've declared a variable called input, then it's going to be referencing that variable or whatever object you have assigned to that variable, and not the input function. So in order to avoid those conflicts, you'll see people put a little underscore at the end of the name. So input underscore would be a way to use that name input, but not shadow the input function. So these are all just conventions. There's nothing like official in the Python documentation about this, but that's really what underscores are there for. That's kind of the two. Well, there's actually more uses of the underscore in Python, but when you see it on like a property of an attribute of a class, it's usually saying that this is a private, meant to be a private attribute. And when you see it used on like a variable name or something like that, it's often used to not shadow some other name in the namespace, usually like a keyword or something like that. I wanted to talk about the question of these properties as well. So Ankit, you said, what are properties in Python? You know about attributes and methods, but what is what is this property thing? And I think that what you're talking about is the app property decorator. Correct me if I'm wrong. But let me share my little terminal again.
Not really, David.
Oh, okay.
I was reading about double underscore dir method, and in the
underscore.
documentation they mentioned the properties thing, which seemed unrelated to the decorator, add property decorator.
And it was the what method, or the underscore what? I missed what you called it.
dir.
Oh, gotcha. Yes. I see what you're saying. So like if you have like some, like if we call like a dictionary, oh, whoops, fat fingers. I don't know, some dictionary here, and then you call, I have to use the actual name of the dictionary. I cannot type this morning. My goodness. There we go. This is what you're referring to, like this dir. Now there is like it lists out like everything that's in the that's like contained in the object, like all the methods and everything. So sometimes properties could be used interchangeably with attributes. So there might be some conflation of those two terms. And I'm assuming you were reading about this in the official documentation. Is that correct?
Yeah.
Now it's possible when they use the word properties, they might be referring to attributes. However, there is sort of a specific difference. You can create what's called a property using the property decorator, and that's where you, instead of defining an attribute and assigning a value to it, you create a function that returns a value, but it acts like you access it like an attribute. So, and I'll relate it to the dir function in just a second. But if I have some class called A, and I have, let's see, let's just have it take some number. Then if I create a, I'll use the at property decorator to create a function called, I'm going to call it double. And it's just going to return twice of whatever the number is that I assigned to num. All right, so I could create an instance of this class. I'm going to call it little a, and I'm going to put the number 2 in it. Now, num here, I can access a.num and get the number 2. That is an attribute, but double is a property, and if I can access this as like it's an attribute, and it returns the value 4. Now it's a function. It's whenever I access the what looks like the double attribute, it's actually calling the double method, computing the value twice times that self.num, and then returning that. It's not caching it in any way. It is really calling that function. So that's the difference between a property and an attribute. An attribute is just assigned a value, and that's it. Whenever you access the attribute, it's just accessing that value in memory and pulling that out for you. A property looks like an attribute in terms of the way you use it, but it's calling a function and it's executing something whenever you call it. So when you call the dir function on the instance of the class that we got here, you'll see double appear as in here, So it's still included. Now you can't tell that is it a property, is it an attribute, is it a method? You can't really tell that information from dir at all, but it does appear in there. So that also might be why they said properties, because technically it's like a different kind of, I don't know. It's like the joining together of a method and an attribute in a weird way. So I think that's probably what they meant. Now, actually, something that I don't know, if I look at the type, interesting. So when I do type of a.double, it's telling me that it's of class int, which is what's being returned by the function. So it's actually like, as opposed to if I do the type of a.dunder init, then it tells me it's a method. So that's something I didn't know, actually. So when you have a property, even though it's technically a method, or it's calling this method, it even like an attribute, it even the type of it is whatever is returned by that. So that's an interesting tidbit that even I myself just learned today. Hopefully that answers your question, Ankit. I think that's what they were talking about there.
I have a question. Like,
Actually, yeah, this property decorator I know a bit about, but as you mentioned, the other meaning of property is people take it for attributes sometimes, right?
Yeah, sometimes it does get used interchangeably.
So the code that I added in the comment there, they are saying that setting attributes and properties, like they are using both the keywords, attributes as well as properties. So that confused me. Like
Oh, I
maybe,
see.
yeah.
Yeah, I think this is probably what they're talking about. Like if you've defined these properties using the property decorator.
Okay. Okay. Thanks a lot, David.
Hey, David, can you just quickly
Yeah.
compare it with the class method? And of course, class methods are basically factory methods, right?
Mhm.
So I see a couple of differences here. Like we are calling it as an attribute. It is a returning type integer, which is kind of similar to the how we call an attribute and what we get in return. So just so that I understand it in a bit clearer way, can you just explain it by comparing it with a class method?
But comparing it with a class method. So a class method, and then I also want to make sure, was it Jinyu, did you also have a question?
yeah.
Okay, I'll come right back to you after I answer this one real quick. So a class method is a method that returns like an instance of the class itself. So like, unlike a regular method that like does something with the current instance, a class method will use it to like create a new instance of the class and actually return that. So you don't have to. I guess the best thing to do here is give an example. So let's say I have, again, this class A, and I do I'm going to have this double method again, but it's just going to be, oh, sorry, this would not, or actually, yeah, let's do double. Now this would, okay, this is not something I do every day. So I believe I do like this. The CLS stands for class, and it's going to be this class A, not an instance of A, but just the class itself. And the number, and then it's going to return so what this is going to do is return a new instance of our class containing the value twice of whatever we gave it here. So let's see how this works. So now if I want to create an instance A it's an instance of my class capital A, but contains twice of the number I give it, I call capital A, right? That's the name of the class, double 2, and now A is an instance of the capital A class that contains the value 4 for its number property. So that's what a class method is it's rather than operating on the current instance. So it's what we're comparing it to is something called an instance method, which is what my original double method was here. It would be like an instance. I mean, really it's a property, but or here in it, I guess, could be considered sort of like an instance method. But you already have, so like you can't just call in the original class A, I couldn't have just called capital A dot double because there's no instance for A. It doesn't know what to do with it. On a class method, on the other hand, you're calling it like on the class itself as opposed to an instance that's already been created. And those class methods generally return an instance of the class that has, that's why you see them called like factory methods, because they're used to sort of build instances of the class in a convenient way. And the difference between that and like this property is that the property, again, is just operating on, it has to be on an existing instance and not some new, it's not returning like a new instance or anything like that. Hopefully that answers your question.
Yes, David, that is really good.
Good.
Thanks, David.
Jinyu, you had a question about all this?
Yeah, I think that is a very good introduction to this class method and property. They are all pretty new to me. So
Okay.
Are they explained in the Python fluent Python book?
Yes, yeah, all this stuff is discussed in Fluent Python, and some of this stuff will be in Python tricks as well. But Python tricks doesn't go into as much depth into like the actual data model. So the data model is all the dunder methods and these things like the property decorator and the class method decorator and all these things. Fluent Python gives a very, very comprehensive discussion of all that. So if you really want to master object-oriented programming in Python, Fluent Python's the way to go.
Cool. Yeah. I'm just still a little confused about like when do you use the class method? When do you define a property instead of just use define a function as a method?
It just depends on I guess what the goal is of what you're doing. So instance methods are when you already have an existing instance, you've instantiated your class and you want to operate on something. So like in that example, you had the linear regression GD, you instantiate that with some information, some data, and then these like the fit method and things like that are instance methods that operate on the data you've passed to that that are on that instance that you've created. So that's like kind of the really traditional way of working with a class. You instantiate it with some data, and then you have instance methods that operate on that data. Why you would use a class method is, let's say you had a trying to maybe relate it to this linear regression idea, but let's say you had a linear regression or maybe some sort of like model class that had certain parameters that you could change, like or like different methods of doing the same thing. So like you had a model that was trying to train something to on some data set and be able to make some predictions, and you could use it doing something like linear regression, or you could do maybe something like a k-means version of that, using like a k-means to instead of linear regression, basically. So maybe it's the same, like you have a class that can handle all of that, but part of the class would be defining, like when you instantiate the class, you would pass some string or something that says, like, use k-means or use linear regression in your for your actual computation. You could have a class method that basically you call the class and then dot whatever, like use method is the name of the, so many uses of the word method going on here. I don't know, style, for lack of a better word. So the style is either k-means or linear regression. So you have like the class name and then dot style, and then you pass to that whatever you want, and it returns a new instance of the class that uses whatever style you want. Hopefully that makes sense. It might be a convoluted description there, but that's really what class methods are for. They're like a factory for generating instances of a class that already have like certain properties set and everything. For you.
Yeah. Okay. Thank you.
All right. Well, we're right at 10 o'clock my time, which is when we end. And actually, I just wanted to mention, Gregor, you said when I was calling type on a.double was just evaluated immediately, and yeah, that absolutely makes sense. That's exactly what was going on there. But anyways, thanks everyone for coming. If there's any quick questions someone has related to all this that we didn't get to answer, I'll stay on for another like 5 minutes if anyone has any quick questions on that.
Why do we use add property decorator? Like, why do we hide the method implementation and show it as an attribute instead? When do we need that?
Yeah, it's really just for convenience. So like if you have a method that always returns like just an integer or just something, and you just like well, actually, I guess I should say one of the sort of the prerequisites for a method to be turned into a property is that it doesn't take any it doesn't have any parameters other than the self parameter, right? So you don't need to pass any arguments to it in order to call it. You would just call it with an empty parentheses. So what it allows you to do is just be able to access it like it were an attribute and just drop those parentheses from it. So it's really kind of a convenience in some sense, just so that you don't have to type those extra parentheses. Because in effect, if you have a method that's returning something and you're not passing any arguments to it, is it really that much different from an attribute? I mean, it has to be calculated each time you call it, but in effect, I mean, it's sort of like it's like an attribute. The difference there is that it could, depending on if it depends on some, if the property, so this method with the app property decorator depends on some other attributes, and those get changed in your program, then you could call that property again and have a different value returned. But in essence, it sort of works like an attribute, because you don't have to pass any arguments to it. So that's kind of the why you use this app property, just a kind of a convenience.
I happen to be reading about that just like a couple weeks ago, and
fantastic.
And one thing that I came across is that when you set up a property like that, you can also set up setter and getter methods.
So, you can,
which is not, I guess, usually part of the Python model. So,
yeah, I mean that does go back quite a ways in Python, and it's been around for a long time. Yeah, we didn't talk about that, and that would be another 20-minute discussion, I think, to go through all that. But you're right, you can have these like setter and getter methods. So, or really, the app property is basically the getter. It really is what that, and then you can set like a setter method so that you could assign something to it, which so then it really starts to look like an attribute. Yeah, there's lots of reasons why you might want to do this. There's lots of reasons why you might not want to do it. It's getting pretty deep into OOP with Python there. But yeah, you're right. You can do the whole setter and getter thing. And real quickly, Richard, your question was class versus module. Can you please draw the distinction? Yeah, a module is a file that uses the .py extension that you can import into another program. So really, any Python file is technically a module. That's what a module is. A class is different in that it's defined inside of a module, and it creates. I mean, there are some similarities, I guess, between a class and a module. A module has its own scope, where you can define names inside of it and everything. So does a class. A class has its own scope where you define names and methods inside of it, and it's sort of contained in the scope of the module that it's defined in. But a module, the main difference is that a module is just a collection of these names, classes, functions, things like that, and you could import that into another program and use that there. Whereas a class is specifically used for creating instances of an object, and that's really the defining difference between those two. All right. Well, I want to thank everyone for joining us, and thank everyone out there on YouTube that's watching with us as well. I hope that this was informative for everyone. Yeah, thanks for coming, and I look forward to seeing everyone next week.
Thanks, Dave.
All right, take care, guys.
Bye.
Bye.